Okay. Section 9.4, Ellipse Part 1. The definition of an ellipse is the set of all points such that the sum of the two distances from the focus points is a constant. So that's a lot to say. Let me draw just a picture of that. So here we have, if we have an ellipse, and let's say there's this, so every point on this ellipse, so there's some point P. If you take the way the ellipse is defined, the way all the points are defined, if you take two points, they're called the focus points, focus, and that's a focus point. They're called foci, the plural of, we don't say focus points, we say foci. These two distances, so we'll label them D1 and D2. Those two distances from the two foci is a constant. So D1 plus D2 is constant. And I'll show you a video if you put like two pins here and you use like yarn that's a fixed length, and then you can draw the ellipse by like rotating around with a pencil. And I'll show you that in a second. So the D1 and D2 is constant, and even cooler is that the sum of these two equals the distance all the way across. So this, and you can kind of picture, if I drag this point over here, can you see that D1 plus D2 would equal the length all the way across? If I drag it here, so this would be D1, D2 would be all of this, but this little distance fits in here. It's perfectly symmetric. This little distance is the same as that, so it would add up to the distance all the way across. And that's known as 2a because of the way we define it. So let me break everything down for you. There's two orientations for this ellipse. One is if it's horizontal and it's like the egg is like on its side. So here's the horizontal orientation like this, and we have this terminology. It's easy to remember though. So if this is the center, this is known as the major axis, the longer one, and this is known as the minor axis, the shorter one. So we need to label these. Major axis, is just the longer one, and this is the minor axis, and this distance here is a, just arbitrarily a. So the coordinates here and here, these are called this is the vertex, are these points. And the coordinates, therefore, since remember everything's centered at 0, 0, what would the coordinates be here? If this is 0, 0, and distance is a, what are the coordinates? Very good. A, comma, 0. And here it would be same distance. What would it be? There you go, negative a, comma, 0. So and so that's what, and the sum, remember the sum of D1 plus D2 is 2a all the way across. So there's your major axis, your minor axis, and then these are called the co-vertex along the minor axis. So this distance is b right here, the shorter. We just make up letters. Okay, so 0b, and what are the coordinates here? If that's 0b, this is 0, negative b. And this is called the co-vertex only because it's along the smaller axis. Co-vertex, and this is a co-vertex. You'll need to know that. Okay, and then the two focus points that we talked about in this picture are going to be here. So I'd say they'd be roughly here and here. And we use the letter C is going to be the distance from the center to the focus point. So this would be C comma 0 for that focus point. And this would be negative C0. And the focus points are always along the major axis. Those are our two fixed points from which we could construct an ellipse. Those are our focus points. So C0 and negative C0 if it's in the horizontal orientation. So we have everything there in that picture. And now let's look at the vertical. So if it's vertical, then the ellipse looks like in this direction. It's like standing up, like the egg is standing up, like so. And so these are our vertices here. This would then be our major axis. This is our minor axis. So this is at 0A. This is at 0, negative A. This is at B0, and this is at negative B0. And our focus points are going to be this way then, here and here. And it would, what are the coordinates of this point? 0C, good. And this is at 0, negative C. And those are our focus points. Okay, and so we have that, and then the equations for each of these. If it's horizontal, it's going to be just this. This is what I want you to use, not the one on your formula sheet. This is all you need today. X squared over A squared plus Y squared over B squared equals 1. And if it's in the other way, it's going to be X squared over B squared plus Y squared over A squared equals 1. And the difference between, for A and B, A will always be greater than B. So the easy way to remember this, if whatever the bigger number, so if the bigger number is under X, then it stretches along the X-axis. And if the bigger number is under Y, then it stretches along the Y-axis. So you really, it makes it so much easier if you remember that. Everything is easier if you remember the bigger number, whichever variable it's under is the way it stretches. And then, okay, then how do we know where this focus length is so that we could find the coordinates of the foci? Well, you need to know what C is. So there's this equation that will be on your formula sheet, and I'm going to explain where it comes from as well. And the equation is this. The equation is C squared equals A squared minus B squared, which we'll be using in a second. So C squared equals A squared minus B squared. So let me tell you where that comes from. So if I draw an ellipse, if I sketch an ellipse, and I pick this point right here for P, for on the ellipse, and here's my two focus points, here and here. Do you see that if I were to pick this point, that these distances, you know the sum of the distance is what? D1 plus D2 equals 2A, right? And so do you see the perfect symmetry here? That means that this side has to be A and that side has to be A, right? Because the sum of these two distances is 2A. So if I draw it perfectly symmetric, then that has to be A and that has to be A. This is a right triangle. This is the focus distance, C, to each focus point, C. And this distance is B, because that's the minor axis in this picture. So you can see from the picture that it's Pythagorean theorem, but it's weird. It's C squared plus B squared equals A squared. right? If I just use this picture. So if I solve for c squared, I get c squared is a squared minus b squared. And that's where this formula comes from. And the larger picture, the bigger idea here is to not get attached to letters. Do you see how if you memorize Pythagorean theorem as just a squared plus b squared equals c squared, and that's the only way you can think about it, that it's not always correct? It depends on where you put the letters. So the better way to think about Pythagorean is leg squared plus leg squared equals hypotenuse squared. And not get attached to letters, because letters we can put anywhere. Okay, so that's where that comes from, and you'll be using that. So now let's do some examples of what you'll be doing in a second. Now you have all the pictures and formulas and vocabulary. So here's what a test objective would look like, and we'll do 2 examples. So graph the equation. And then you're going to find these things. You're going to find the vertices, which are along the major axis, the co-vertices, and the foci. That's your goal. Given the equation, you're going to do all those things. So first example is x squared plus y squared equals 1. Okay, so it will be helpful to you. The very first thing you should look for is, oh, the bigger number is under y. So is this a horizontal ellipse or a vertical? It's vertical. It stretches along the y-axis. So I'm going to sketch a picture so I know that a squared is the bigger number. So a squared is 49. And so a is 7, and I'm going to write vertical just to remind myself that it's, because, okay, and then I'm going to sketch a picture, and I'm going to plot the point 0, 7, and 0, negative 7, just roughly. Okay, so I know it stretches that way, and I know in the minor axis direction b squared is 36, so I know that b is 6. So I go 6, 0 this way. It almost looks like a circle. So you go 6, 0, and you go negative 6, 0, and then you sketch it. It's supposed to look longer in the y direction, but it almost looks like a circle. Okay, so those are, so far I have my vertices. That's along the major axis. The coordinates, I'm going to give you the shortest way to write it. 0 plus or minus 7. You can write it like that. That takes care of both. 0, 7, and 0, negative 7. And then I'll let you abbreviate for co-vertices, CV. Those are the ones along the minor axis, so it's plus or minus 6, 0. And then the focus points. Well, you know the focus points are always along the major axis, and they're actually closer to the center. The more it is like a circle, you'll notice the closer they are to the center. So so this is going to be 0 comma something. It's going to be 0 c, and this is going to be 0 negative c. So we need to use our formula though to figure out what it is. So we know it's 0 comma something because it's along the major axis. And it's plus or minus c, but we got to find c. So what you do is, off to the side, you're showing your work, you're using c squared equals a squared minus b squared. So c squared is, a squared was 49, the bigger number. It'll always be the bigger number minus the smaller. B squared was 36. So c squared is 13, or c is plus or minus root 13, which you should simplify if you can, but you can't, so the focus points are at 0 plus or minus root 13. And so you would box that, and you'd have your graph. Okay, so that's how you do these. And now I'm going to give you a problem to try right now that I can check to make sure you know what you're doing, and then we can start. the worksheet. So the second example that you'll do on your own, this is you try, is 9x squared plus 25y squared equals 225. And there's one step here that I have to show you. This is not in the doesn't look like the equations I gave you. Because in the equations I gave you, there's no number in front, and this is a 1. So all you have to do, whatever this number is, you just divide it by it. You divide by this number. That's your first step. If you don't see a 1 over there, you want to make it a 1. And if I'm going to do it on that side, I have to do it on this side. And conveniently, all the problems you'll be given, 9 will go evenly into 225, so it'll go away, and so will 25. So you get x squared over 25 plus y squared over 9 equals 1. And that's something that you can work with. So I want you to work that all the way through. I want you to sketch it. Well, is it horizontal or vertical? Good, because the bigger number is under here. So you know that a squared is 25, or a is 5, and it's horizontal. So that'll get you started. You're going to sketch it and name the vertex, the co-vertices, the focus points, and sketch a picture. And I'll come and check it, and once I'm convinced your team has it, I'll give you the worksheet.